Good morning, everyone. This is Dr. Andrea Botazato. I'm an assistant professor and Enology extension specialist with Texas A&M, Texas Agrilife Extension Services, and this is a webinar that's part of our Enology webinar series. Today, we're going to discuss winery wastewater management, and our presenter today is Mr. Richard Aller. Mr. Aller is a water resources engineer in a private practice in Texas. Aller Engineering, Inc. was started in 1989 as a consulting design firm specializing in water resources that includes water and wastewater reuse design. Mr. Aller is currently the president and CEO of Aller Engineering. He has been involved in several wastewater treatment systems for wineries in West Texas. His experience includes passive treatment systems to advanced treatment using membrane bioreactors. Currently, Mr. Aller is completing a design for a large development using membrane bioreactor systems with 100% reuse of the treated effluent. Mr. Aller's first wastewater treatment facility design started with a trip to Napa Valley, where his team spent 2 weeks touring various wineries behind the scenes to learn how technology was being used in the overall design of crush operations, piping, cooling the juice, and the eventual treatment of the waste from the winemaking process. Aller Engineering, Inc. continues to be involved in various wineries, from permitting to overall facility design, including reuse of the enhanced wastewater reclamation process. Thank you, Mr. Aller, for being with us today. Before we begin, I'd just like to mention that this is going to be more like a conversation, a discussion, if you will. So if any of the attendees have a question, please raise your hand. I will unmute you, or you can type your questions in the chat box or the Q&A box on your screen. I cannot unmute everybody because we have over 100 people registered for this webinar. So I will unmute as needed. And without further ado, Mr. Aller, thank you again for being here today. Please take it away.
Thank you. Let's start first by talking about some of the experiences that we've had in the overall planning process when we start a winery. Typically what we see, and that would probably be on the topics page. Let me put that up. So in the planning process, and I've been through several of these, both as new wineries and as existing, we find that there's not necessarily a lot of detail provided for how we are going to handle the waste that's generated from the process, winemaking process. So some of the components that we ask for and is what type of wines are being planned to be produced. That's important from our standpoint because of the various ways that they age the wine in barrels and the whole process that they use with in fermenting the wine. So that's important to us to understand so that we can certainly provide the right type of treatment to handle that waste load that's being produced. The other thing is we want to know kind of what your volume is. So how much wine are you planning to produce? You know, and normally we try to talk about that in a phased approach. So if it's a new winery, how much are you planning to do in the first year of operation? Where do you plan to go in 5 years, plan to be, and then out to 10 years? And we like to try to get at least out to 20 so that we have an idea of what we have to provide for a treatment process to handle the flows and the type of wines that are being produced. And then we want to talk about, you know, what's the ultimate disposal strategy? What are you going to do with this treated wastewater once you treat it? Are you going to discharge it to a stream, a river, or a lake? If you are, then that dictates a completely different type of treatment process. And we have a lot more regulatory issues that we have to have to look at and design for. Are you going to do it on an on-site treatment and disposal? So are you going to reuse this as irrigation water, possibly? And then what about the screenings and the stems and the skins and what we term as screenings from the crush process and actually fermentation process, because we're going to get some of that out of there when we transfer from tank to tank. What's the ultimate disposal process that we can use for that? Can we use that and till it into the soil on your site? Do you have enough land to be able to do all of that? And what we find typically is we start asking these questions, and we like to be early in the process because there's a lot of times not a lot of thought given to that. And so it certainly impacts the overall design of the winery if we haven't addressed some of those issues early in the process. So, you know, if you're going to have a barrel room, you know, how often are you going to rotate those? How are you going to clean those? We find that cleaning processes vary, you know, from winery to winery. Some places use really sophisticated and low volume cleaning processes, which we absolutely promote, particularly here in Texas, where water is becoming a scarcity for us, and all the easy water is gone, already claimed by cities and other water districts. So it becomes pretty prudent on our part to identify those water resources based on what the plan is for the winery. If it's an existing winery, then we go back in and ask about the process already. You know, take us through the process. We want to walk through it with you. We want to see what's going on, and we want to understand the characteristics of how you operate and what type of waste is being generated. So we go through the same process of questions, and we try to characterize that wastewater, the waste from the winery, as precisely as we can. So what the other thing that we find in all this is that the wastewater that comes off of these wineries is very high in chemical oxygen demand, COD, and BOD, which is biochemical oxygen demand. So it's a biological process that we use to clean up both of those. And so we find out, we look at that, we pull samples to really get a full characterization of what that is. That dictates what type of treatment works best for that particular installation. So those values are a measure for us of the quality of the wastewater coming out. And what we find is most of the time the COD and BOD are in the neighborhood of 3.5 to 4 times of what you would normally find for domestic sewage from municipalities. So it's a pretty strong waste, and it requires specific treatment processes to be able to treat this to a level that we could, number one, discharge it if that were the case, or even to use it as irrigation water. So both in new construction and in existing wineries, if we go in and we're asked to characterize and help them with upgrading or creating a new treatment scheme, we're going to do all of the same questioning. We're going to try, if it's an existing, obviously we're going to pull some samples to really define what we're working with. If it's a new one, then we have to make some assumptions based on prior experience and other facilities and design it going forward using that type of information. So once we do that, once we kind of characterize what kind of waste that we're working with, and we then know what type of discharge we're going to have, you know, are we going to be, like I said, discharging to a stream or a body of water of some sort, or we're going to reuse it on the land. Then that guides us in the direction of the different types of systems that we might be able to use for treatment. So typically what we see are on-site wastewater treatment facilities. That's pretty common. Those can include ponds. Some cases, those can include even enhanced septic systems, like an enhanced septic tank and drain field. Most of the time, they're ponds, and we term those passive systems because we're also allowing Mother Nature to help degrade the strength of the waste. And aerated ponds or aerated lagoons are probably the most popular because of the loadings that we have. Loadings being the organic and inorganic COD, BOD that comes to these systems. If we use aerated, we can actually use a smaller footprint, so a smaller pond, and we're inputting mechanical aeration into that system to accelerate the treatment process. If we're looking at something where we're actually going to discharge, then more of a conventional activated sludge plant is typically used. Today, what we're seeing, that's a large investment. That's permanent structures built, on the site or in the ground. And today, what we see is technology is advanced enough that packaged treatment units that are pre-manufactured and we can set down, add to the treatment chain if necessary, are extremely good to use, and particularly with wineries. And even if we have a nitrogen or phosphorus removal requirement, we go with an advanced treatment for that to remove those. Those can be added to a package treatment system. So our direction for treatment for us today, and with the people, the clients that we work with, we normally, if we can do it on site, and we're going to reuse and irrigate agricultural crops, maybe grapes or even pasture land, for example, we'll tend to go with aerated ponds. If we need to enhance that treatment, then we go with packaged treatment units, and then the next step would be a tertiary step, which would be reducing nitrogen and phosphorus, and that we would add some other trains to the packaged treatment units that we use just initially for the treatment. So that's kind of what we see. We start from like I said, from characterizing. We like to be in on the planning part. It's very important to think about that when you start developing new wineries, is how we're going to handle the waste, what are the requirements, what are the state and or primarily state regulations that you have to identify. So it's prudent to do that early in the process. That helps you be much more cost effective in your treatment at the end when we actually start the design. So anybody have any questions at this point?
I do, about regulations. Would you be able to talk a little bit about this, regulations in Texas in regards to winery wastewater?
Yeah, it's first of all, you have to get what they call an industrial permit for a wastewater treatment facility in Texas. A little bit more stringent than a municipal, but not a lot. They still, on a regulation, still look at the BOD loading, which is the standard loading. They're now starting to switch to the COD, only because it's a quicker analysis, so you get results quicker than the BOD. Other than that, it follows the same regulations. Different areas of Texas have groundwater protection areas, so you have to make sure that that you're not, if you're going to irrigate, that you're not irrigating over a rechargeable aquifer like the Edwards Aquifer in Texas. They regulate the volume of discharge. So that's written in your permit that you have a maximum hydraulic volume that you can treat and discharge. They also regulate how you handle sludge if you're producing sludge. So, you know, one of the advantages of the passive systems like aerated ponds is that you don't handle sludge in those. On the other side, the mechanical systems, you do generate sludge, so you have to have a sludge disposal spot where you can get rid of that sludge. Typically, that is done by tilling it into the soil for a winery. That requires an additional permit to be able to get that done. It's based on land area so that you don't oversaturate that soil and leach anything into possible groundwater contamination. And the process to do the permitting takes 12 months from start to finish, and that's if everything goes smooth. So there's a lot of detail involved in the permitting process, and all of that has to be submitted for their review. I've had, in all my years of experience, I might have had 3 to 5 permits that went through without any question. But typically you get questions, and so that kind of delays the process, and that's why in Texas it's called the Texas Commission on Environmental Quality. We call it TCEQ, and that's why they recommend and stipulate that it takes a year to process a permit.
Thank you. We had some Federico Garzelli raise his hand. Federico, do you have a question? You have to unmute yourself. I cannot unmute you. If you have a question, please let us know. No? Okay. All right, so we can continue then. I don't see any other questions at this time from our attendees. Mr. Aller?
Yes. So let's talk a little bit about advanced treatment so that we kind of get an idea of what that really includes. Advanced treatment and we only use that if we have a discharge requirement for the winery. So we're going to be discharging to what we call the waters of the state. And typically we will find today that we have a nitrogen and soon to have a phosphorus limit placed on discharges that enter the waters of the state. So to do that, conventional treatment can be designed to remove nitrogen but not phosphorus. And so when we do advanced treatment for that, we try to do both nitrogen and phosphorus. We'll knock both of those down. There are several different ways that we can do it. Typically for phosphorus, we do it with chemical addition. And we put chemicals in to react with the phosphorus, and it comes out in the sludge production. If we're doing strictly nitrogen, and that's the only concern that we have, then sometimes we do that using RO systems, reverse osmosis systems. That seems to be the easiest for most of the people in the wineries to be able to operate. So one of the things we try to design to is the level of operations. So what level, you have to be a certified operator in Texas to be able to operate these plants. So what level of operations do we have at these facilities? So we don't want to over-design a very complicated system for the operators that have to maintain it to be able to do that. And typically that ends up, in most parts, being the owner of the facility has to take some classes and get certified as an operator. And so we try to keep it pretty simple, and that's why we try to use package treatment units, or we really try to stay on the passive side if we have the land area available, and use aerated ponds or aerated lagoons, because there's not, and the reason it's called passive is simply that. There's not a lot of changes you can do to the treatment system to accelerate the process or change the results that come out on the effluent. So it's a passive system, where the mechanical system is much more complicated, but we can do a lot more with it. But we try to keep it pretty simple in our designs, because your primary purpose in all of this is making wine, not necessarily, working on wastewater. So we want to try to keep it just as simple as we can, but that's typically what we would do if we had a discharge situation where we were discharging to waters of the state, and we certainly had these parameters that we had to meet, and before we could discharge, then we would probably look to use a reverse osmosis type system. All of those come in various sizes, easy to do, pretty easy to operate. Doesn't take a lot of chemical or process background to be able to do that. And so those are the two primary systems that we use today.
We have a question about the permit.
Okay.
The question is this permit the same regardless of the size or the location of the winery?
Permits are specific to each winery. So you have two major components in a permit. You have a hydraulic, which is how much water you're going to be putting to the wastewater treatment process. So you have a hydraulic limit, and you have an organic limit, or a BOD, COD limit. So they're very specific to each location and each winery.
So how are these limits determined then for each winery, for each location, and how are they measured? You mentioned that the volume of the discharge is regulated. How is this measured? How is this controlled?
It's controlled by flow meters that we have to install on the discharge side and on the inlet side of the wastewater treatment plant. And parameters are set by water quality at TCEQ. They're pretty similar to all the municipal type. Typically what we see today for a passive system is a 50 milligram per liter. If you're going to irrigate on site or irrigate agricultural land, then we'll see a 50 milligram per liter BOD, COD level, and typically 100 milligrams per liter of total suspended solids, TSS is what they call that. That's typically what we see written into those permits. On the other side, if it's some type of reuse that we want to try to get other than just irrigating agricultural land, so let's say we want to irrigate land around the winery that has public access, then we have to meet a more stringent parameters for the effluent quality, and those are typically what we see is 20/20. So 20 milligrams per liter of BOD. Sometimes we see it as down to 10, and then same thing for total suspended solids. So each facility is unique, and all that has to be described in a permitting process. And then it's a give and take. There's a lot of communication that goes back and forth between the regulating entity, TCEQ, and the owner and the engineer that's designing it. They have opportunities to discuss some of the limits that are proposed in a draft permit.
All right, I think Chase has a comment. Chase, you commented about the volume. Do you still have a question about that? You are unmuted now. You can talk, Chase. Hello? No? Okay, we have a question, another one from Jose Pedro Ferraz. doesn't the use of passive system lead to pollution of the water resources and the land around, or are they enclosed?
No, they're not enclosed because we want the sun and the atmosphere, the air to also interact on the pond surface. These ponds are lined, so we don't get any infiltration through the bottom of the pond. They're typically lined with clay and or bentonite, or we can use a synthetic liner if we have to put in there. But all of them are lined so that we don't have any. Let me put it this way: we certainly reduce the risk of any infiltration of that water into the ground below. So we try to avoid and typically do. I've never had any leak. Avoid any contamination of groundwater underneath those.
Thank you. Any other questions at this time? No. Okay. Mr. Aller?
Yes.
Yeah. Is there, would you like to continue, or we're still waiting?
Is there anything else that you would like to expand upon?
Well,
let's go that way.
Myself, I would like to get a little bit of a better understanding of the pros and cons of these systems, maybe, you know, in general terms, and maybe a little bit of discussion in terms of cost.
Okay.
Thank you.
Okay. So let's talk a little bit about ponds and just how the design goes. So there's a surface loading rate that's typically put upon us for ponds. So let's say we use a pond that's not aerated. That becomes a very large impoundment because I'm pulling up from my memory now. I think the loading on that is somewhere like 75 or 100 pounds BOD per acre per day or something. So the ponds get very large if we don't have some type of mechanical aeration included in that. And if we don't have aeration, if it's just a passive pond system, you normally have 2 or 3 of those ponds in series. So the first one removes some, and then the second one has a lower loading rate, so it's a little bit smaller, and a third one has another loading rate, and it's a little bit smaller. But they take up several, acres of land to be able to do that. They're also pretty shallow, so somewhere in the neighborhood of 3 to 6 feet, 3 to 5 feet is typically what we see for those ponds, and they solely rely on Mother Nature to help do the degradation of organics and that enter that system. If we do an aerated type pond, then our footprint becomes much smaller, and our loading rates go up so that we can make it smaller. And so that tends to be the best option. A lot of times we're limited on space. So the aerated lagoon allows us to get it in a smaller space. We go deeper than 5 or 6 feet so that we don't have any scouring caused by the aeration system, any scouring of the bottom of the lagoon or pond. Costs of these vary, and the biggest reason it varies is because of the liner requirement. If we have clay readily available, and in Texas we have what we call playa lakes, throughout different areas of Texas, and then we also have a lot of clay in Texas. So if we can find a clay material to line the pond with, that's the cheapest alternative in building them. Second, then we have to go to a synthetic liner, and then that becomes more expensive to do. And so it varies. For us to say, that in all cases area lagoons are by far the cheapest. We can say that for West Texas because we know that to be true, but in Central Texas that doesn't always follow. So you're talking somewhere in the neighborhood of, if we do an area lagoon, about $125 a cubic yard. That includes excavation and also includes the liner material to go down. What we've seen lately, I'll be honest, is that prices are all over the place for this kind of stuff, and so trying to predict what a cost might be has been very difficult in the last 12 to 18 months. And a lot of that's due to the amount of work that's already out there for contractors that do this type of work, and material has been extremely hard to get. So that's raised the cost of all this considerably. But overall, the cheapest option to use is aerated ponds. And that's because of the smaller footprint. Then it goes to, you would think it would then fall back to the other passive system, which is just ponds. Like we talked about, stabilization ponds is typically what you hear them described as. Those are not necessarily cheaper because of how big they are, how big they turn out to be because of the loading requirements. So from aerated, we go to packaged treatment units. Packaged treatment units are, like I said, steel construction. They're all steel tankage. They bring them in on the back of a truck. They pick them off the truck, set them where you want to set them, tie the line in, put electricity to it, and you're up and running pretty quick. Those units cost anywhere from $100,000 on up to get those, but they're a fully functioning treatment unit when you get it. So as you go into advanced treatment, as we talked before, that's adding another treatment train, as we call it, to an already packaged treatment unit. Depending on the size of those vary in cost between about $50,000 to $150,000. And advanced treatment consumes a lot of energy. So not only do you have a capital expenditure that you're adding to it, but you're also adding an O&M expenditure to run it because they are high pressure systems pulling a lot of voltage to be able to run the unit. The other ones are not so bad. Packaged treatment units are not energy intensive. Aerated ponds are not. I've used recently solar aeration units, so they have solar panels on them, and so we harness the Mother Nature again and use it to provide the aeration for the ponds. So a lot of alternatives out there. That one seems to be catching on. It seems to be pretty popular using the solar panels.
We have a number of questions at this point. The first question that came in from Luke was, what sort of solid separation devices do you use?
Well, the majority of the solids that we get, if we're using a package system, is we try to do screening certainly at the crush area, and then in the wine production area through screens and drains and that kind of stuff. We try to capture it there. On the package units, we typically use a fine screen at the headworks of the unit. Those are whatever comes through is typically from what we call process water, wash water. The fine screen catches anything that is not caught in the wine process portion of it, and we normally would capture that and put it in a dumpster, and we either haul it to an approved landfill or we reprocess it on site by tilling it in. So we typically will use a fine screen to do that.
The next question comes from Jose Pedro Ferraz, and the question is, so basically the debris is sedimented in the bottom of the pond, and when they are empty, then what can we do with the sediments?
Sediments, the pond is designed to have a 20-year life. The sediments will be high in nitrogen, typically. We just closed a pond system 2 weeks ago in West Texas. The sediment was very high in nitrogen, and so what TCEQ allowed us to do, we proposed that we would take the sediments out, spread it on agricultural land, and till it in. And they allowed us to do that. And then it was a pond system that we closed. And then we took the dikes and pushed the dikes in over the top of what was left. But we took out as much of the sediment as we could get. And then we just covered the rest of it with the dikes that were there.
Question from Sergio Hernandez. If I already have a pond that I use the water for irrigation, can I use this pond for discharge as far as it is aerated?
No, not without first. If he doesn't have a permit for it, then you would have to go back and seek a permit for that particular pond. And if all that was in place, then yes, you could actually put aeration on it, I believe. I don't know all the specifics, so I have to know a little bit more, but I have used lagoons that were built as stabilization ponds. I have put aeration units on those and was able to extend the useful life of those ponds by doing that.
All right, the next question comes from Brian, who says, are smaller wineries legally bound to get a permit? For example, a winery producing 500 to 1,000 cases. What's the realistic cost-effective setup that will be practical for such a small operation? Who is the regulating branch of government which enforces permits? Had we not enrolled in this webinar, many of us would have not realized wastewater enforcement was an actual regulated topic. At what point during the process of trying to start a new winery would this topic be brought to our attention? Would my winery permitting attorney assisting with the TTB application process be the one to know this was a requirement? So I guess a number of questions here. We can take them one at a time. Yes.
Yeah, let's take the first one. If you would repeat that one, please.
Yes.
And
are smaller wineries legally bound to get a permit? For example, a winery producing 500 to 1,000 cases.
Wineries are required to get a permit from TCEQ. If it's a small winery, the one we just did was a very large winery. It was one of the first ones that we designed. It was originally the Tasha, or what now is Caprock Winery in West Texas. It started out with an aerated pond system, and they have reduced their production. And so we closed that permit. And I don't know how many cases they're doing now. And what we did was go to an on-site septic system with an extended drain field. So we did more drain field than you typically would do, say, for a house or something, because of the strength of the effluent coming out. So we designed more drain field. We have 2 septic tanks in series, and that's a good alternative for small wineries to have. And so that process, since we had to close a permit, we had to get TCEQ to agree that a on-site system would work. A lot of times, if you're a small winery, you just have to do that through the county that you're in and get approval to use a septic system to do that. So I would say probably a septic system in this case would be a reasonable way to do that.
I guess that answers the second question. What's the realistic cost-effective setup that will be practical for such a small operation? Yeah. Who is the regulating branch of government who enforces permits?
So permits, like I said, for a winery, they're industrial permits, and Texas Commission on Environmental Quality are the regulators of that. If you have a permit that's under TCEQ issuance, then the local TCEQ inspectors that will come around, like they go to all the cities and check all of them, they will also come to your facility and they will check on your treatment process, and they'll want to see records of lab analysis of the effluent, and they'll want to see how you're maintaining the facility and all that kind of stuff. So you're subject to regulatory control and inspection. They do an annual inspection typically, and then they do quarterly inspections just to see that you're maintaining the facility like you should, and you're creating an effluent like you're supposed to under the issued permit. So TCEQ, if you don't have a permit and you're using a septic system, then typically it's the county, and there's nothing. Once you get approval to put the septic system in, then there's nothing else that you check. I mean, they don't pull water quality analysis from a septic system.
I guess the final question was, would the winery permitting attorney assisting with the TTB application be the one to know this was a requirement?
Yeah, that's typically what we see, is that unless it's a very large winery and they realize that they're going to have a lot of water coming out of it, nobody really knows, and nobody's really telling anybody that that's something you need to be concerned with. So, it's mainly based on flow. How much water how much wine you're going to be producing tells us about how much water you're going to have. But I don't know why that communication is not out there. But you just need to be aware that depending on how much water you produce, you may be subject to acquiring a permit through TCEQ.
Another question from Jose. So all the chemical products we use in the winery won't be dangerous for our fields or water resources after the passive treatment?
Typically not. I mean, a lot of that stuff will be tied up in the sludge that settles to the bottom. Mainly what we have is you're going to have some acids that are created in the process. We got some polyphenols that are created from yeast that's used. All that gets tied up typically in the sludge. The aeration helps accelerate the oxidation of that stuff, and that's why we use aeration to do that. So it's typically not harmful if you use the water as irrigation water, as long as you don't concentrate that application in one spot, but you spread it out over acres of land. Then most of that gets taken up in the root of the plant and doesn't truly affect the land. Now, if we concentrate all that effluent irrigation in one spot, then obviously we supersaturate that area, then it can become an issue. But if we spread it on a large area, then it normally does not get below the root zone of whatever plant we have planted there, and so it's taken up into the plant.
This is a question coming from myself. I'm curious, do you know in Texas, on average, how much water does a winery use to produce 1 liter of wine, and how does that compare to other states or other places?
I wish I knew that. I don't, because they vary so much. Some places, Caprock, we're working with them right now here and reducing their their water use for cleanup. So there's not just a good gold standard that says here's the average they produce, because it all varies by the way they do their cleaning operation. We're using some automated cleaning at Caprock to clean barrels, because they do some barrel fermentation, and so that's a lot more efficient than the hose and nozzle that they used when they started. And the reason it became an issue here is because they have wells that they use for their water supply, and their wells are starting to recede in production. So there's not any water in that area that they can develop a new wells to help augment that supply. So it's really hard to say, because it's all based on process and how the process is handled. I've helped clean a lot of facilities in my day, and cleaning tanks and all that, and I invariably find while we're cleaning that we're using a hose and a nozzle, and a lot of people won't shut the nozzle off completely while we're maybe inside scrubbing the tank or whatever we may be doing, and so all that water ends up at the wastewater treatment plant is what happens.
So I guess that would lead me to my next question. What are some ways of reducing water use in the first place in a winery? Are there certain systems, practices, pieces of
there's some good standard of practice to use. I don't like to see a lot of alkalis that used in cleaning. I know we do that a lot, particularly in tanks and stuff to get residue and stuff off of the walls. But probably the best practices that I have seen are having a standard procedure of how, if you're going to do it manually, here's the procedure, and the procedure is all involved about more back and arm muscle than water pressure. And so you reduce the amount of water that you're using, and you have to do more cleaning manually. And so you're only rinsing. You're not trying to use necessarily pressure to clean that off. I've also seen high pressure units used, spray wands used, which reduces the amount of water used for cleaning and helps with getting residues and stuff off of surfaces. That doesn't use a lot of water, because your water source is being pressurized through the nozzle, so that helps. There's automated barrel cleaning systems out there now that are the same principle, or using high pressure nozzles to clean it. And so you set the barrel over the top of some of these, or on a 45-degree angle, and it cleans the barrel rather quickly, and reduces the water use. So cleanup on the tankage floors, we have gone to the high pressure nozzle again. I think it runs about 2,000 psi that we use, and it doesn't use a lot of water. So we've reduced our water consumption in many of these places by doing that, and it has helped immensely. Now, the downside to that is, flows to the wastewater treatment plant likes a pretty constant flow to operate correctly. And, what we see is variability in flow, being high during crush and low in the off season. And so we have to adapt our treatment to accommodate for that. But some of the best practices are getting away from the hose and nozzle and going to more of a high pressure system for cleanup, and then reduce your chemical usage as much as possible.
Is there any chance we could use rainwater for the winery?
There is. You could use rainwater for a lot of the cleanup, where it comes in touch with tankage and where we're doing process issues, then we'd have to do another step with rainwater, which would be capture it, chlorinate it to make sure we don't have any bacteria in there before we could use it for any contact with what they would call food stuff, is the way they term that. So can you use it? Absolutely. Can you use it to clean the floors and that kind of stuff? Yes. And that's a good alternative, good augmentation to your water resources.
In order to get a permit, does one have to have a certified engineer to design a plan and install the system?
Yes, they do. It has to be designed by a registered engineer in the state of Texas, and a permit has to be done by a registered engineer as well.
And your firm does that, correct?
Yes, we do.
Thank you. All right, these are all the questions I have so far. Are there any more questions? If not, we're gonna start wrapping up. Mr. Oller, do you have anything to add at this point, if there are no more questions? Maybe we can get in touch with you for that?
Yeah, you can get in touch with me. It's Oller Engineering. My email address is rich, R-I-C-H, Oller, O-L-L-E-R, at OEI-ENG.com.
Perfect. Thank you. All right. Well, we have no other questions at this point.
Well, thank you for having me. I thoroughly enjoyed it.
Absolutely. Thank you so much for being here today. This was very, very interesting, very informative. I'm sure a lot of people learned a lot today. To all the participants, I would like to ask you, before you leave the webinar, please take 2 minutes to fill out the survey that will pop up at the end of this presentation. It helps me keep the program going. I know many of you have done it before, but I would appreciate it if you do it again today. Just 2 minutes of your day. Thank you. Thank you again, Mr. Oller, and we will see you all next time. Have a good day.
Thank you. Bye-bye.
Bye-bye.